Hi everyone, myself Praveen Kumar and I am pursuing BE Mechanical in BITM Bellary. And today I am here to present a seminar on homogeneous charge compression ignition engine. And firstly we will see the contents of HCCI engine. What is HCCI engine? Importance of HCCI engine, principle, potential, barriers, control methods of HCCI combustion, prototypes of HCCI engine, advantages and disadvantages, conclusion, reference. And firstly we will see the what is an HCCI engine. HCCI is a form of internal combustion in which the fuel and air are compressed to the point of auto ignition. That means no spark is required to ignite the fuel or air mixture. It creates the some amount of power as a traditional engine but uses less. Basically, HCCI is a perfect and high effective innovation for combustion engine that can be scaled to any major classes of transportation engine and also utilized for stationary applications. A correlation between the two engines shows that the SI engine furnished with a catalytic converter gives low discharge, however needs efficiency. The diesel engine gives high efficiency but delivers high discharge of nitrogen oxide and particulates. And we'll see the importance of HCCI. SI engines have very low nitrogen oxide and particulate matter emissions. CI engines have high efficiency, and homogeneous charge compression ignition is a promising alternative combustion technology with high efficiency and lower nitrogen oxide and particulate emissions. And here it is a working principle of HCCI. HCCI is characterized by the fact that the fuel and air are mixed before combustion starts, and the mixture auto ignites as a result of the temperature increases in the compression stroke. And optical diagnostic research shows that HCCI combustion initiates simultaneously at multiple sites within the combustion chamber. Now, how does it work? A given concentration of fuel and air will spontaneously ignite when it reaches its auto ignition temperature. And the concentration can be controlled several ways. Those are high compression ratio, preheating of induction gases, forced induction, retaining or reintroducing exhaust gases. And comparison with other other engines. Here we can see the three types of engines. Those are SI engine, CI engine, HCCI engine. In first figure, that is SI engine, the additional spark plug is provided for ignition purpose, and in this hot flame and high emissions. And next comes to the SCI engine, and here also the additional fuel injector is provided for ignition purpose, and here hot flame and high emission will be there. And next HCCI engine, here there is no spark plug and no fuel injector, it's auto ignition, and also here low temperature maintained and very low emissions in this combustion engine. This is the difference between these three engines. And now comes the potential of HCCI. High efficiency, no knock limit on compression ratio, low nitrogen oxide and no nitrogen oxide after treatment system required, and low PM emission, no need of PM filter. HCCI provides up to 15% of fuel savings while meeting current emission standards. HCCI engines can operate on gasoline, diesel fuel and most alternative fuels. And these are the barriers. The auto ignition event is difficult to control, unlike the ignition event in spark ignition and diesel engine, which are controlled by spark plug and in cylinder fuel injector respectively. HCCI engine have a small power range constrained at low loads by lean flammability limits. and high loads by in cylinder pressure restrictions and high compression and CO emissions. Here, the control method of HCCI combustion. The spontaneous and simultaneous combustion of fuel-air mixture need to be controlled by no direct control method is possible in SI and CI engines, and various control methods are variable compression ratio, variable induction temperature, variable valve actuation, and we will see that variable compression ratio method. The geometric compression ratio can be changed with a movable plunger at high top of the cylinder head. This concept used in diesel model aircraft engine. And next comes variable induction temperature. In this, the simplest method uses resistance heater to vary inlet temperature, but this method is slow. And next, now fast thermal management is used. It is accomplished by rapidly varying the cycle to cycle intake charge temperature by rapid mixing. And here that is variable valve actuation VVA. In this method gives a finer control within a combustion chamber, involves controlling the effective pressure ratio. It controls the point at which the intake valve closes if the closure is after BDC. The effective volume and hence compression ratio changes. And here is the HCCI prototypes. Generally motors has demonstrated Opel Vectra and Saturn Aura with modified HCCI engines. Mercedes-Benz has developed a prototype engine called Tias Auto with controlled auto ignition. It was displayed in its F700 concept car at the year of 2007 Frankfurt Auto Show. And advantages of HCCI: it can achieve up to 15% fuel savings, and lower peak temperature leads to cleaner, lower emission, and it can use gasoline, diesel, or most alternative fuels. And HCCI automobiles could reduce the greenhouse gas emissions. And the disadvantages are highly cylinder, higher cylinder peak pressure may damage the engine. Auto ignition is difficult to control. HCCI engine have a smaller power range. And here it is a conclusions. Nitrogen oxide emissions decrease firstly at low premixed ratio and exhibit a trend of increasing at higher premixed ratios. The change of CO with premixed ratio is mainly depending on whether the premixed equivalence ratio exceeds the critical value. An SCCI can be used as an alternative engine for SI and CI engines. On application of 10 to 15% of thermal efficiency can be increased. Helpful for go green, and HCCI engine still needs a lot of developments. And these are the references which I have referred. And thank you.